This third video finalizes the discussion on the Wagenmakers et al. Article on the logic validity of the p-value. So again, we are still keeping on the realm of the philosophy of science, and this particular video is going to deal in perhaps with the more philosophical, so to speak, argument, and this is assessing the validity of the Modus Tollens via its transformation into its contrapositive, the Modus Ponens. If the second is also consistent, then the first will be consistent as well, and vice versa. Now, this discussion could become confusing very quickly, so I'm going to rely quite heavily on the written presentation rather than on me talking, so as to minimize confusion and to speed up the whole video. So I will put here a slide dealing with this contraposition of Modus Tollens into Modus Ponens. And as we can see, a valid and consistent Modus Tollens can be transformed into its Modus Ponens, into its contrapositive, via two operations at the same time. The first is to contrapose the antecedent and the consequent and negate both at the same time, right? And then upon obtaining the Modus Ponens, then we can use this logical syllogism to reach a conclusion via the affirmation of the antecedent. The same relationship between a valid Modus Tollens and a valid Modus Ponens is kept when dealing with the logic underlying frequentist statistics. Now, when we look into Wagenmakers et al. Syllogism, the Modus Tollens that they pose in their article, and try to create this contrapositive, we face two problems. So I show very quickly here. First, the contrapositive of the first premise now reads: if a significant result is probable, then the null hypothesis is not true, which reads a bit strange, because normally there is not. Although Wagenmakers et al. Said that, as we discussed in the first video, I discussed in the first video, there is no an attachment to. There's no probability attached to the level of significance. That means a result is significant or not. It's not probably significant or not. So that is, we don't normally confuse the significance of a result with its p-value, which is the probability of the result under the null hypothesis. The second problem is the conclusion itself. And there we can see that this conclusion achieved or becomes probabilistic when the consequent in the Modus Ponens is not probabilistic itself. So, this is the same issue that we discussed, or I discussed in the second video, and it's much more apparent in this case. So to me, this exemplifies that the Modus Tollens used by Wagenmakers et al. In their article is not consistent, and therefore is faulty in its enunciation. These two problems are more apparent when we use an example, that of the Pope. All right. So when we look at the contrapositive of that example, this contrapositive will read, if an individual has a low probability of being the Pope, then this individual is not a man. And here we obviously find quite evident the absurdity of that premise. So we don't need to conclude to wait for a conclusion to find it absurd, because when we transform the contrapositive of the Modus Tollens into the Modus Ponens, we see that it was absurd to start with. And the second problem obviously is that probability transposed from the antecedent onto the consequent as well is not warranted. Now, to be fair to Wagenmakers et al., I would like to now show where I think they are coming from. Okay, so I will show it quickly here. And I will start talking from the modus ponens they would like to achieve, or they are thinking of, and then use the contrapositive of that modus ponens into modus tollens. So the modus ponens will read like, if a result is significant, then the null hypothesis probably is not true. And upon finding a significant result, then we can certainly conclude in a valid manner that the null hypothesis is not true. And this is a valid modus ponens, which I think nobody will argue against. Now, when we look at its contrapositive, this modus ponens will become and will read as, if the null hypothesis, or if a null hypothesis is probable, then we will observe a non-significant result. So upon observing its opposite, a significant result, we can conclude that the null hypothesis probably is not true. And again, this conclusion is valid. It's actually the same conclusion that we achieved earlier with the modus ponens. And actually, what these two syllogisms show is the logic underlying Bayesian hypothesis tests, which, I will repeat, is not the same that frequentist hypothesis tests. Basically, as we can observe, frequentist tests do not use probabilistic hypothesis. They use true hypothesis, all right? So, because we are not using probabilistic hypothesis, we cannot conclude a probabilistic assertion against that hypothesis either. On the other hand, the probability of the results, which is in the consequent of the modus tollens, of the frequentist modus tollens, is resolved by the observed level of significance in the second premise, and this probability cannot be transposed into to the antecedent via the conclusion. In fact, let me show you very quickly the modus ponens that underlines frequentist statistics. So, for example, if a p-value is lesser than 5%, for example, this p-value can be read in two ways. Okay, one is that's the probability of the data under the null hypothesis, which is equal to the probability of making a type 1 error if rejecting the null hypothesis. There will be a literal descriptive reading of the p-value, but also we can use that threshold as a level of significance, as discussed in the first video. And therefore, what we are doing is cutting the null hypothesis into two regions, one where we reject the null hypothesis and one where we accept it. Alright? So that same p-value lesser than 5% can be read as such level of, the threshold of that level of significance. So upon obtaining a p-value that falls on that region, we could actually conclude either that a rare event occur, well, an event that occurs less than 5% of the time, for example, or that the null hypothesis is not true. And this is something that Fisher wrote down about as a possible conclusion. But what is important to remember here is that a test of significance is only based on the null hypothesis, and therefore the first interpretation, the probability of the results under the null hypothesis, once it's significant, has no further meaning once we do the test. Like, yes, it can be read this way, but it doesn't make sense when we are using a level of significance, because it's this the level of significance and not the p-value that determines the validity of the syllogism, the modus tollens underlying the logic of rejecting the null hypothesis according to the p-value. So it's when we use a level of significance under this logic, then basically what we are saying is a p-value that falls under this rejection region is going to be used as evidence to reject the null hypothesis. Not to talk about the probability of this null hypothesis, but to reject it or not. And from here we can then simplify this modus ponens, and we can find its contrapositive. And if we do so, and I will put it quickly here, we come all the way around to where we started. The logical basis of frequentist statistics, of frequentist data tests, is based on a valid modus tollens. If the null hypothesis is true, then we don't expect to see a significant result, or we expect to see a p-value greater than 5%. And upon observing a result that contradicts this consequence, so for example we observe a significant result or a p-value lesser than 5%, we can use this observation to contradict the antecedent, and therefore to conclude that the null hypothesis is not true.